Hi, my name is Abhishek Lingwal and I am a graduate student at North Carolina State University. So, I will be presenting you my third homework in CSC591 DevOps course, that is Proxies, Queues, Cache, Fluency. So, in this project what we have done is we have used NodeJs to start a new web server and handle the user request, and then by using an in-memory database key value store such as Redis to store the result from the web server back to the Redis and retrieve it back from the Redis. So, over here I will just show you the setup. I just clear my screen first and stop my Redis server, so that I can have a fresh startup. So, what I will do is I will show you my proxy.js file. So, in this my project consists of two parts, that is proxy.js, which is a proxy server. So, my any user request will go to the proxy server and that proxy server will redirect it to the web application server running. So, this proxy server is listening on port 8008, and what it does is it basically gets the available servers from the Redis and redirects the request to that particular web server. In the main.js, this main.js is basically implementing various user handles such as set and get operations, resend operation, upload operations, spawn a new web server, or destroy an existing web server, or list the available servers, and how the proxy is working. And it uses Redis as an in-memory database system to store the values. So, I'll just show you. I'll just start my Redis server first. So, you can see my Redis server has started. It's listening on port 6379. Next, I will start my proxy server, and I will start my web application server. So, my proxy server is listening on port 8008 as I have shown you. So, what I will do is I will show you one basic operation such as set first. So, what this is doing is this is basically sending the request back to the web server, that is a proxy server in this case, and that proxy server is redirecting to one of the available web servers, and this set operation basically sets a particular message. In this case is hi, this message will expire in 10 seconds. So, what it does is it stores this string in the Redis web server and sets the expiration time like 10 seconds from the time it created. So, if I do a get operation which should get me the the value set by the set operation, I will not get anything because it has my 10 second has been passed. So, I will do a set again and do a get again quickly to show you that my values are getting set in the Redis server. So, you can see I am able to retrieve my value from the Redis server. So, if I do get again, I will be not able to see my key again. So, and the next operation is resend, which basically shows you the last 5 visited URLs on this particular web application server. So, if I do resend, I can see my last 5 URL request, which is resend, get, set. So, this basically how it's doing this is like it's pushing the data to the Redis queue. So, as soon as I have a new URL, that URL get pushed to the Redis queue, and when I request for a resend command, it basically removes the top 5 means the last 5 pushed values to the stack. So, this resend works in this fashion. Now, I will show you the upload, and I will show you how I can upload the image into the Redis by converting the image to a base N64 format and then retrieve the image back from the Redis server. So, what I will do, I will basically simulate a upload command. So, what I am doing using curl for that. So, I am passing one of the sample images over here with the upload handle. So, as soon as I do this, I can see over here that I got the long list of base64 encoded image, and I have stored this into the Redis server. I can confirm that by showing you my from the Redis client that the value I have stored. So, if I do L range image data, you can see that I got this long image data which I have pushed right now. So, this image data is getting stored in such a fashion that if I have uploaded this image right now and I try to access this image will be displayed, and I will be not able to see that image again because that image is basically removed from the queue. So, if I do mu, I am able to see the image, and now this if I do in the Redis server again lrange, I am not able to get that image back again because it has been removed. So, if I do mu again, it will show me no image data to be present. So, I will just try to push multiple images so that I can show you that effect. So, if I push the same image again, and I will push a different image again. So, now I have stored 2 images into the Redis server, and I will do mu. So, my first image is this one. If I do mu again, I will be able to see the next image which was uploaded into the Redis server, which is this one. If I do mu again, I have no more image to show you. So, this is how my upload and mu operations are working. It uses ltrim, lpush and lrange operation of the Redis database system. Next, I will show you how I can spawn a new web server. So, a new web server can be spawned by using spawn command. So, you can see it successfully spawned a new web server on port 3001, which I can confirm by doing some arbitrary request over here. I will do a set request. So, you can see I am able to perform the same command on port 3001 too. So, what I will do, I will try to spawn some of these servers. I will just spawn randomly 10 servers. So, it's listening on this particular port, and I can confirm the same from the backend too. So, if I go over here, I can see that this app is listening on this particular port, all these ports, and my proxy is basically getting the request. So, now I have this all list of spawned servers. If I want to view that, I have another command called as list servers, which will list all the running web servers. And what happens is, whenever I do a spawn, it starts a new web application server on a different port and stores it particular detail into the Redis queue, Redis list. So, what happens that I start a new web server and I store the port number on which this particular web server is listening. So, now if I do, there is another operation called destroy. So, what it does, it selects one of the random running ports from the Redis list and destroys it, removes it from there. So, it destroyed 3011. If I do destroy 3009, it is destroying it randomly. So, I destroyed 3 So, if I do list server again, I will see that the destroy ones are not no more visible over here, and my list got updated with the relevant values. So, over here you can see how I can, using the spawn, I can spawn a new web server. So, if suppose my load on the system is increasing, I will just spawn some new web services. So, they are available to serve the user request. Similarly, by using destroy, I can destroy the servers, so that the number of running web servers on my system is reduced. And by using list server, I can get an idea about the running web servers on my particular system. Now, I have shown you that proxy is the one which actually gets the user request first, and then it selects one of the running web server and forwards the request to that. So, I can show you that behavior. So, first, for example, if I do a set operation right now. So, if I go to the backend on the console, I will be able to see that over here it sent the request to 3007 port, the web server running on 3000. If I do set again, it sent to 3001. If I do set again, it sends to 3000. So, over here you can see that my user requests are getting distributed across the web servers running. So, this is kind of a load balancing system where the user requests are getting distributed across the various web servers running. So, in this way we can see that how we have implemented a load balancer using a proxy server and Redis to basically get the available list of servers running on that particular system. So, this is how I implemented proxy. So, thank you.